Hey guys, welcome to my channel, Technology and DIY. As you may have noticed by the title, today I'll be talking about what CPUs are and how they work. Let's get right into it. So first of all, you may ask, what is a CPU? The term CPU stands for Central Processing Unit and is arguably the most important component of your PC, smartphone, or tablet, but isn't the computer itself. It's just the brains of the operation. It is a component that is responsible for telling all the other components in your device, such as the hard drive, RAM, which is random access memory, GPU, your graphics processing unit, and controls the other components in a computer according to the instructions it is given by computer programs or software such as Windows, Mac OS, or Linux. The CPU sends instructions to other components in your device by contacts in the motherboard CPU socket, which leads into controller chips on the motherboard. These controller chips then relay instructions to other components such as the GPU. Overall, there are three types of CPUs, each with a different method of making contact with the motherboard. These include LGA, which are LAN grid array, which is the socket in which the pins are on the motherboard and make contact with metal pads on the CPU. Then there is PGA, which stands for Pin Grid Array, which is the socket in which the pins are on the CPU and each have dedicated holes on the motherboard in which the contacts are. And the other type is BGA, which stands for Ball Grid Array. It is a socket in which there are solder balls on the CPU, which are placed on the motherboard and heated up to melt and make contact with both components. This makes the CPU a part of the motherboard, and the sides are usually sealed with black adhesive. This adhesive is usually non-conductive. In modern computers, and especially in smartphones, the CPU may sit on the same physical chip as other components. This is known as a System on Chip, or SoC, which is a chip that contains its CPU alongside other components such as the Wi-Fi modules, GPS modules, and security modules. Most computer GPUs share a chip with the computer's graphics processing unit, which is the technology that allows you to connect to an external monitor via VGA, HDMI, or DVI ports. An example of an SoC CPU is the Intel Core i7-7700K. How does it work? As mentioned before, a CPU takes instructions from the software in a program or application and performs a calculation. This process can be broken down into three key stages: fetch, decode, and execute. A CPU fetches the instruction from a system RAM module and then decodes it into what the instruction actually is before it is executed by the relevant parts of the CPU. The execute instruction or calculation can involve basic arithmetic, comparing certain numbers together, or moving them around the memory. Since everything in a computer is represented by numbers, those kinds of simple tasks equate to what a CPU does. It's what facilitates everything from starting up Windows to watching a YouTube video. Originally, processors had a single processing core. Today's modern processors are made up of multiple cores, which allow it to perform multiple instructions at once. There are effectively several small CPUs, each with billions of transistors on each chip. Almost all CPUs sold today are at least dual-core, but at the higher end you'll find 4, 6, 8, and even 12-core CPUs in some cases. Some processors also employ a technology called multithreading, which creates virtual processor cores. These cores aren't as powerful as the physical cores, but can help improve a CPU's performance. Now let's talk about processor speeds. Clock speed is the term which is given to the speed at which a computer runs at. It is written in the term gigahertz, with the prefix giga standing for billion and the suffix hertz standing for times per second. When put together, 1 gigahertz means 1 billion times per second. Now you must be wondering, how does 1 billion times per second have anything to do with the CPU speed? Well, in a CPU, the gigahertz value stands for the amount of times per second a CPU can complete instructions. These instructions include the fetch, decode, and execute ones I showed before. The CPU requires a fixed number of clock ticks or clock cycles to execute each instruction, because of which the faster the clock speed is, the more instructions a CPU can handle per second. Now that you have watched this video, I hope you understand the very basics of how a CPU works. Thank you for watching, like, subscribe, and if you want to, please share.